Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about this specific example here where you have this complex function. This is a trigonometric function and you are asked to find the values of x such that the graph of this one here will have a horizontal tangent. So when we talk about a horizontal tangent, mathematically this means that when you differentiate the function here and you have to set it equal to 0, and by solving this equation you'll be able to find the values of x at that position where the tangent is horizontal. Okay, so that is what we are going to do. We are going to start off with finding the derivative of this function here. So here we go. I'm just going to write down the function, which is secant of x 1 plus tangent of x. And we know that we can assume this to be f and the bottom part to be equal to g. And we can apply the formula, which is gf prime minus fg prime over g squared in order to find the derivative of this function here. Okay, so let's get on with that. So here the result is going to be equal to g is 1 plus tangent of x. Now if you differentiate this function here, you will get secant of x tangent of x. Next, minus f is secant of x, and if you differentiate this, this is a constant, so if you differentiate that you will get 0, plus if you differentiate tangent of x you will get secant squared x. This is over 1 plus tangent of x squared. Okay, next what we can do is perhaps we can take down the brackets. So we're going to multiply the terms respectively, and here you will have 1 multiplied with secant x tangent x. You will get the same term, which is secant x tangent x. Now plus, so here is going to be multiplied with this term. You will get secant of x tangent squared x, and here this is going to be simplified and it's going to look as such. Okay, over 1 plus tangent x squared. Well, it doesn't look any simpler, so maybe what we can do is we can try to factor out secant of x and see how that looks like. Yep, so factor out secant of x, and here we get tangent of x plus tangent squared x minus secant squared x over 1 plus tangent of x squared. Now I hope that you will be able to recognize this part. So this is something that should be familiar to you if you remember the basic trigonometric identity, which is 1 plus tangent squared x is equal to secant squared x. So this is the trigonometric identity, and you can play around with this equation here, and if you see that, you can write down this equation here as such. So we can have tangent squared x minus secant squared x is going to be equal to -1, and we know that this is the expression which you are seeing right here, and because of that you will be able to replace this whole thing here with the value of -1. Yeah, so that's what I'm going to do next. I'm just going to write down the answer, which is going to be secant of x, now tangent of x plus and this value is going to be -1. So plus -1 is just -1 over 1 plus tangent of x squared, and that is the answer to derivative of this function given here. Alright, so the next step is we are going to set this result here equal to 0, and we're going to solve for x. Okay. So hang on a bit, I'm just going to erase the space here, erase the ink here so that we have some space. Okay. Right. So what we have next is I'm going to set the result here equal to 0, yeah? So here we have secant of x tangent of x minus 1 over 1 plus tangent x squared must be equal to 0 in order for us to have a horizontal tangent. And I hope you can see that based on the construction of this equation, you will see that the factors that play a role in making the whole expression here becomes 0 are these two factors here, secant of x or tangent x minus 1. So if this is equal to 0, then the whole thing becomes 0, or if this becomes 0, then the whole thing here becomes 0, yeah? So based on the construction of this equation, we can say that there are two scenarios here that you can consider. The first one is secant of x is equal to 0, or tangent x minus 1 must be equal to 0. So either these two scenarios will result in the expression here becomes 0, okay? Now if you consider the first scenario here, secant of x is just 1 over cosine of x, which is equal to 0, and based on this equation here, there is no solution. There is no value of x such that if you plug in into this expression here, the result is going to be 0. So no solution to this, so we are not going to consider this equation. Now if we move on to this one here, tangent x is equal to 1, and we know that this is a special value which you have learned in trigonometry. Just hang on, just going to erase this part. So I'm sure you have seen this in trigonometry before, which is if you have an angle of 45 degrees, and if you find tangent 45 degrees, the result is going to be equal to 1. So this is some sort of a special angle which we have learned before. Tangent of this angle is equal to 1. We can consider 45 degrees to be the reference angle, and because the value here is positive 1, therefore we know that angle of 45 degrees is going to be either on the first quadrant or it is going to be on the third quadrant, which is here. Okay, now remember what you have learned before. Add sugar to coffee. So if you get a positive result, then sine, cos, and tangent here on this quadrant is all positive. Here is just a positive sign for sine theta, and here is just a positive sign for tangent, and this one is a positive sign for cosine. And since here is a positive value, we know that the angle of x is going to be either on this quadrant or the third quadrant, yeah? Alright, so now we are going to find the values of x such that tangent of that is equal to 1. Okay, so first of all, let's look at the possible values for this one here. Okay, so for this one, okay, so I'm just going to change this. Okay, so here for this scenario here, we know that definitely x is going to be equal to 45 degrees, because when it is 45 degrees, then the tangent of this angle here is going to be equal to 1. And since there is no specific range for the values of x, therefore if you make a 360 degrees and you stop at this position here, you will get the same value if you plug in tangent of that angle. So x can also be 45 degrees plus 360 degrees. Okay, if this is 45 degrees and you go for a round of 360 degrees, so the angle is going to be equal to 405 degrees. And if you consider this angle, tangent of 405 degrees is also going to be positive 1. And this can go on continuously. For example, if you do another round of 360 degrees, and if you stop here, the tangent of that angle is also going to be equal to 1. So here we have 405 degrees plus another 360 degrees. This is going to be equal to 765 degrees, and this is going to continue on because again there is no limit to the range of x. Okay, now if you consider this part here, okay, this one, x is equal to, this is actually 180 degrees plus 45 degrees, yeah, so x is 45 degrees plus 180 degrees, and this is equal to 225 degrees. And similar to the argument which I have said just now, if you make a turn of 360 degrees and you stop here, again the tangent of that angle is going to be equal to 1 as well. So here if you add 225 degrees with 360 degrees, the angle that you get here is going to be 585 degrees, and tangent of 585 degrees is going to be equal to 1. And in a similar manner, if you continue the process, if you go for another round of 360 degrees, you will get tangent of the angle equals to 1 as well. So if you have 585 degrees plus another 360 degrees, this is going to be about 945 degrees. So tangent of 945 degrees is going to be equal to 1. So the pattern here is not going to stop, it's just going to continue on and on. Alright, so what we can do is we can write down the final answer. Well, if you want, you can write down the final answer in terms of pi instead of degrees. So if you want to write down in terms of pi, this is actually pi over 4, yeah, 45 degrees pi over 4. This one is actually pi over 4 plus 2 pi, because 360 degrees is 2 pi, and this one is pi over 4 plus 2 pi plus 2 pi. So that is 405 degrees is pi over 4 plus 2 pi. So plus another 360 degrees, which is 2 pi, yeah. And here, if you see, this is actually pi over 4 plus pi, 180 degrees is pi, and this one is pi over 4 plus pi plus 2 pi, and here we have pi over 4 plus pi plus 2 pi plus 2 pi. Okay, so you can see that this is If you simplify it further, this is pi over 4. This is pi over 4 plus pi. This is pi over 4 plus 2 pi. This is pi over 4 plus 3 pi. This is pi over 4 plus 4 pi. This is pi over 4 plus 5 pi. So there is some sort of pattern which you can write down your final answer. So here we have x is going to be equal to pi over 4, pi over 4 plus pi, pi over 4 plus 2 pi, pi over 4 plus 3 pi, pi over 4 plus 4 pi, pi over 4 plus 5 pi, and it is just going to continue in this manner. All right. Okay, I think that's all for now. Thank you very much for watching.